these that we're going to talk about today are the three great areas of equilibrium: KEQ, KSP, and K sub A, K sub B. KEQ is equilibrium constant. All three of these talk about how much reactant turns into product. So if you have a big K, it means you have a whole lot of product. If you have a K that is the number 1, it means at equilibrium you have equal amounts of reactant and product. And if you have a little tiny K, it means you mostly have reactant and you hardly got any product. So by doing this calculation, a chemist can tell at a glance whether or not a reaction gives you a lot of product or not. This is called moving to the right, since reactants are on the left and products are on the right. The first thing we're going to look at is equilibrium constant. This means you put things together and you make something new. For example, we have A plus B yields C, and these are our coefficients, the 1 to 3 to 2 ratio. No. The bigger the K, the more product. So we can calculate this K. The K is the product of the products raised to the power of the coefficients divided by the product of the reactants raised to the power of their coefficients. It's product over reactant. You can't remember, it's PR, alphabetical order. So we take our product, C. We use brackets because we're not using numbers yet. We're using formulas. And it's raised to the second power. We use our coefficients as the powers. Over A times B raised to the powers of their coefficients. We take the molar concentrations at equilibrium, we plug them in, and we'll get a number called a K. And again, the value of that K will tell us whether we get a lot of product or not. If it's something like 0.02, we hardly get any product. If it's the number 1, we have equal amounts. And if it's a very large number, then it means we have a whole bunch of product. So you'd have a big number on top, a little on the bottom, that would give you your big K. The next thing we can look at is KSP, solubility product constant. You might have to move back. Solubility product constants are how much a salt comes apart. In KEQ, you're talking about mixing things together and making something new. In KSP, you're not. You're talking about, here you got a salt, you put it in water, how much does it come apart? Now you'll notice this is what we call a mass action expression. It has a top and a bottom. It includes the products and the reactants. When we talk about a salt coming apart, we do not use a mass action expression. We only deal with the concentrations of the products. It measures how much a salt comes apart. So this is a 1 to 1 to 1 ratio. We're only going to deal with the product, solubility product constant. So we'll put our sodium raised to the first power and our chlorine raised to the first power. Again, we'll use molar concentrations. Here's another example. Magnesium chloride comes apart into 1 magnesium and 2 chlorine. Therefore, when we do that KSP, we have magnesium raised to the first power, but our chlorine raised to the second power.